Hello grade 12 American System, this is Mrs. Nancy, your chemistry teacher. We are going to continue our section 22.1 Hydrocarbons. Today we are going to learn how to draw structural formulas for straight chain alkanes. So please open your book to page 766. To draw the structural formula for a straight chain alkane, first write the symbol for carbon as many times as necessary to get the proper chain length. Second, complete the formula with hydrogens and lines representing covalent bonds. Sometimes a shorthand or condensed structural formulas work just as well. So, what is a condensed structural formula? In a condensed structural formula, some atoms or bonds are left out of the structural formula. Table 22.3, it shows several ways to draw a condensed structural formulas using butane as an example. So like we have molecular formula, C4H10, complete structural formula, like I explained it before. We have condensed structural formula, the carbon skeleton, and finally the line angle formula, where carbon atoms are located at each intersection and at the ends of the lines. So now let's do sample problem 22.1. Drawing structural formulas for alkanes. The question is, draw complete structural formulas for the straight chain alkanes that have Part A, 3 carbon atoms, Part B, 4 carbon atoms. So, first, as I said before, each carbon atom forms 4 covalent bonds to hydrogen or to other carbon atoms. So we start with the number of carbons, then we write the hydrogens. Each center carbon bonds to 2 hydrogens, each end carbon bonds to 3 hydrogens, as you can see here in Part A. And make sure that each carbon has 4 bonds. Part B, we draw 4 carbons. Number 1. Draw complete structural formulas for the straight chain alkanes with 5 and 6 carbon atoms. So first we draw 5 carbon atoms and we make sure that each center carbon bonds to 2 hydrogens and each end carbon bonds to 3 hydrogens, and we do the same thing with the 6 carbon atoms. Question number 2. How many single bonds are there in a propane molecule? Look at the propane molecule below. The propane molecule is made of 3 carbons bonded to 8 hydrogens. If you count the single bonds here, so there are 10 single bonds. Alkanes and other hydrocarbons do not always have carbon atoms bonded in straight chains. Because the carbon atom forms 4 covalent bonds, it can bond not only to 1 or 2 other carbon atoms, but also to 3 or even 4 other carbons, resulting in branched chains. So, look at the diagrams below. The longest carbon chain of a branched chain hydrocarbon is called the parent alkane, like propane and hexane. And all other carbon atoms or groups of carbon atoms are regarded as substituents. So what is a substituent? It is an atom or group of atoms that can take place of a hydrogen atom on a parent hydrocarbon. A hydrocarbon substituent that is derived from an alkane is called an alkyl group. So what is an alkyl group? An alkyl group can be 1 carbon or several carbons long. Alkyl groups are named by removing the ane ending from the parent hydrocarbon name and adding YL. 3 examples of alkyl groups. We have methyl, ethyl, and proper. Methyl, CH3, ethyl, CH2, CH3, proper, CH2, CH2, CH3. So when a substituent alkyl group is attached to a straight chain hydrocarbon, branches are formed. So as I explained before, an alkane with 1 or more alkyl groups is called a branched chain alkane. So each carbon in an organic molecule can be categorized as a primary, secondary, tertiary, or quaternary carbon. Look at the figure below. We have methane, 0 carbons attached, CH4. Look at the second one, primary carbon, when we have 1 carbon directly attached. Secondary carbon when we have 2 carbons attached. Tertiary carbon when we have 3 carbons attached. And quaternary carbon when we have 4 carbons attached.